want to go on to a little different topic now. On the next slide. If we look out into space at the light that comes from distant stars, we see, for instance, black lines in the spectrum where hydrogen gas has absorbed some of the light. And we know what those lines are on the Earth, that where hydrogen, as it is on the Earth, absorbs the light. And when we look out far away in space, we see that these lines have moved toward the red part of the spectrum. We call that a red shift. And so the question is, what is happening? And in the next slide, I show the measured redshift due to gravity. Now, this was measured by Pound and Rybka at Princeton University in the tower there, and they measured the redshift, Z, in terms of gravity and the mass of the Earth and the radius of the Earth. And it wasn't a very big value, but they measured it. They measured it going up the tower and coming down the tower. So it was different. One was a blue shift and one was a red shift. And they proved that there was definitely a relationship between gravity and the red shift. And in our theory of gravity, gravity is decaying. The mass is decaying. G remains constant. The mass is decaying, and R is getting larger over time. And so we asked, well, how much bigger could it be than it is today if we were there on day one of creation? And the answer is, if the electrons don't vibrate beyond the size, the current size of the atom, they could be as much as 10 to the 9th power as large as it is today. And that covers the size of all measured redshifts in the universe. So we predict that when we see the stars at different parts of the universe, that we see light coming from an earlier time, closer to the creation, and that the closer we get to the creation date, the larger the redshift, because the stronger the force of gravity was at that time that affected the light coming from those stars. And of course, the stars would have been smaller, so we get a very big effect. And so the interpretation we give is in agreement with Hubble's interpretation that the main part of the redshift, the part that is called Hubble's law, is due to gravitational redshifts, not Doppler redshifts. So let's go the next slide.
One quick question.
Hubble's constant is a model-dependent constant. Let me show you some more things here, and we'll get to that. The next slide. There are two possible sources of redshifts, okay, that we would expect. We expect the main part of the redshift to be due to the gravitational force, but the objects, the stars in our galaxy and in other galaxies in the universe are moving. So we do expect a Doppler shift. We expect a local Doppler shift due to the local motion of the stars. And so we think that should be a rather small effect compared to the main effect, which is due to gravity. So there's two sources here, a Doppler shift and a regular the decay of gravity. The next graph shows Hubble's actual data that he took. Notice there's a straight line drawn through the data, but the data does not lie perfectly on the straight line. Some data lies above and some lies below. And so we interpret that deviation from the straight line as being due to galaxies or stars moving away from us or moving toward us. And so if they move toward us, there's they move away from us, there's a redshift. So when the ones that are higher, they're moving away from us, and the ones that are closer, the direction that they're moving is toward us. So we know that some of the stars in the universe are moving toward us, and some are moving away, and so that seems to fit with everything that we observe. It also, Hubble never believed that the Doppler shift accounted for all of for his law. He thought it was strictly related to distance, and that was the view that he had. So our model is able to explain all the redshifts. We do not need a separate theory of special relativity, or we do not need another theory of general relativity theory or anything like that to predict these redshifts. Okay. The next slide shows additional data, more recent. You can see it's still within the uncertainty. It doesn't lie perfectly on a straight line, but it's still fully compatible. And this is going out a much larger distance than Hubble was able to measure in the time that he did his measurements. So to all distances that we can measure, it appears that this linear relationship with distance still holds, and the farther away, the longer it would take the light to get to the Earth, and the farther back it passed you would be seeing. And so the farthest back you could get would be to see light from something very close to the time it was created. Next slide, please.
Question.
Sure.
How do they measure that distance? I thought the distance was measured by measuring the redshift.
I will get a little bit into that, I think, toward the end of this presentation. So give me a chance to get there, and then we'll ask that question again. There's different methods at different distances, and you try to have the one method overlap to the next so that you can confirm the next method that might not be directly confirmable without some other evidence to support the idea. So what you have, you start out with triangulation, and then you work out to different methods. And I'll cover. We explain all the methods in terms of this universal force law. So I'll try to get to that in the first. We're really going slow here. This next slide is TIF's redshift periodicities. TIF examined the redshifts in terms of power laws, and he was able to discover a regularity, a periodicity in the redshifts. Now, according to general relativity theory and the Big Bang theory, there should be no periodicities. Okay? Periodicities, if you have a universal force law, which says the elementary particle has a center, the atom has a center, the nucleus has a center, the solar system has a center, our galaxy, the Milky Way, has a center, then if it's a universal force law, then the universe has a center. If the universe has a center, then the redshifts, if the matter in all the universe is in bands, just like there are planets, which are bands about the sun, for Bode's law, then all the matter in the universe should be in bands about the center. And so if we plot redshifts, we should find we have very little redshifts in between these bands. And that's what TIF discovered. And he found a way to see it. And it turns out it's not real easy to see because we're not at the center of the universe. But he was able to detect this periodicity. The next slide. On the right-hand side, if you're, let's say, you're 2 million light years from the center, this is the kind of pattern you would expect. And if you're at the center, this is the kind of pattern you would expect. So we know where the center of the universe is because there is a redshift of the cosmic background radiation, and from that we've been able to determine where the center is for cosmic background radiation at least. And if you correct all of the redshifts to be what you would see from that point, then you actually see these well-separated peaks, and you see a good number of them. And that indicates that there is a center to the universe. It is not, according to general relativity theory, there is no center to the universe. There's no extent, there's no size to the universe, it's infinite. The Russell-Humphreys island universe, in terms of general relativity theory, has a finite-sized universe and a center. But many people don't care for that particular approach to general relativity theory. But anyway, I just want to point out that in general, the Big Bang theory has no center, and it has no edge, and the universe is uniform. It is, it doesn't have any banding or like that, so it cannot explain this type of data. Okay, the next slide. Tift was a very active man, and he discovered that all redshifts
Dr.
in the
Lucas,
universe.
the question was, where is the center, if we know where it is?
In the paper that I gave to Daryl, by the way, I gave Daryl Ayers a copy of this presentation and two papers in PDF format. One is the derivation of the universal force law, the force of gravity from the universal force law, and one is the derivation of the force of inertia from the universal force law. In there, in the references, you'll see exactly where it is. It's a paragraph or two describing how you measure it and where it is. I'm sorry I can't quote it right off the top of my head. I don't have that paper up on my computer at the moment. Okay, but it's not my opinion as to where it is. It's generally accepted in the astronomical community that is where the center of the cosmic radiation is if you determine that by redshifts. And of course, Tift's work would find a similar place. His work confirms that is the center. In fact, he got the best separation of the peaks when you corrected all the redshift data from all the stars that we've measured to be from that point. But Tift did one other thing, and that is, in this slide here, he found that all redshifts are decaying, and decaying fairly rapidly, faster than is possible with the Doppler shift interpretation of redshifts. He had to publish this anonymously because he didn't want to lose his job and everything, but people know who did it. And he published all the data and showed that all the redshifts are decaying. Of course, from our origin of redshift being due to a gravitational redshift and all gravitational forces, masses decaying over time, we explain that they all have to be decaying. If they're not decaying, our theory of gravity is wrong. So we predict that they all should be decaying. This was measured, though, before we did our theory, so we just found the data and show it to you. Now I want to show another type of data. If you go to the next slide. This is a spiral galaxy, and the blue data on here is the velocity of the stars in the spiral arms as a function of distance from the center of the spiral galaxy. And the green line is what Newton's universal law of gravitation predicts, because we know how to measure the mass of the stars and the mass of the galaxy. We have other methods that are fairly accurate for measuring that. And so what we find is that there's not enough mass in the galaxy, in the spiral galaxy, to explain the velocity of the spiral arms. People have promoted a modified Newtonian dynamics that is able to predict or to agree at least with this data, but it doesn't agree with Newtonian dynamics. And people who don't want to modify Newton's laws come up with what's called black matter and black energy. Black mean you can't see them, and they would say, for instance, in a typical spiral galaxy, that 9/10 of all the mass of the spiral galaxy is black matter, dark matter, and 1/10 is visible matter that you can see. And that explains this. Now, what does our approach to gravity say? Well, we say that the mass at the center of this galaxy is no longer as large as it was originally, and the mass of the stars on the outer spiral have also decayed. In fact, the outer spiral masses have decayed faster than the part that's in the center, because our mechanism for decay, which is by radiation, we can have both radiation, emission, and absorption. So in the middle of a spiral galaxy, you have a lot of absorption of what's being emitted, and only from the surface does it actually decay, whereas when you get out to the spiral arms, there's much more ability to radiate the energy away more quickly, and so the mass declines faster. So what we find is when the spiral galaxy was originally formed, it wasn't a spiral galaxy, it was a ring galaxy, and that after it was formed, it started to decay, and these spiral arms are the stars escaping from the spiral galaxy, and they haven't gotten completely away because it hasn't been very long ago that they were created, and that they still have the kinetic energy that they had when they were bound in the ring, but their kinetic energy gives them too high a velocity with the current mass that they have to be considered bound. Now, if you believe the universe is billions of years old, then these spiral arms are still bound, and you need more mass to hold them in place with their current velocity. So what we have is we have an explanation that doesn't require modifying any of the laws of physics, doesn't require inventing dark matter or dark energy, and it gives a very self-consistent explanation for these and explains the current velocities that we see. The next slide shows a number of these curves for various spiral galaxies, and this approach appears to be able to explain the more than 900 of these spiral galaxies that have been observed that have too high a rotational velocity. Okay, so there's another piece of data that no previous theory of gravity has been able to explain. And inventing dark matter, which you cannot see, and you can't produce any dark matter in accelerator experiments on the Earth, that's really way out there. And so we don't take those outlandish views. We stick to conventional classical physics, which doesn't do that sort of thing. And we're able to explain what is observed. The next slide talks about the Tully-Fisher relation, and that is if you measure the luminosity of galaxies and you measure the rotational velocity on the outer edge of these, the outer spiral arms, you find that they're not random, that they have a linear relationship. And so what causes that? Well, we would predict from Bode's law that spiral galaxies have matter in bands, and that the size of the spiral galaxy is one of those bands. And so they would be quantized, and there would be a relationship between the energy coming out and this size. Now, people have studied that in great detail. The next slide shows a study of 900 of these rotating spiral galaxies, and we find that this luminosity, or velocity versus size or distance, is definitely there. You can see from the graph that it is very, within the uncertainty of the data, it's almost a perfect fit. And so people have then said, well, if we do the power structure like we did for redshifts, can we see something? And the next slide shows the galaxies exist in discrete luminosity states and discrete sizes. And we see the same kind of quantization like Bode's law represents in the sizes of spiral galaxies. And so we've now seen Bode's law not only in our solar system, but we've seen it in the redshifts for all the matter in the universe, and we see it in the size and the luminosity of all the rotating spiral galaxies that we can identify. So it looks like the evidence is overwhelming that this theory of gravity is superior to all previous theories of gravity. It can explain more astronomical data than all previous theories of gravity put together, and it explains it better, and it doesn't have to invent outlandish things like dark matter. It doesn't have to worry about non-conservation of energy, non-conservation of momentum. Everything's explained in terms of this approach. The next slide shows the conclusions then that we can make concerning this theory of gravity. Gravity is due to the force between vibrating neutral electric dipoles, which are electrons and protons and atoms. There is a non-radial gravitational force term. We've shown all kinds of evidence for its existence. It causes all the quantization. It causes the toroidal ring, the motion of everything in a toroidal ring on all size scales in the universe. We see that mass is not a fundamental quantity, which is assumed in general relativity theory and Newton's universal law of gravitation. We see that G is not a fundamental constant. It's just a combination of electrodynamic quantities. We see that the cosmic background radiation is from all these vibrating neutral electric dipoles. Hubble's redshifts are produced by stronger gravitational forces in the past that we see when we see light from the past. Redshifts decay over time, we predict. The quantization of the planetary orbital radii, Bode's law, and the axial spin are all electrodynamic in origin. We see the high rotational velocity of the outer stars and spiral galaxies are due conservation of energy and decay of mass in spiral galaxies. And we see the quantization of luminosity and size and mass of spiral galaxies are all electrodynamic in origin. The next slide shows the advantages of this electrodynamic force of gravity over all previous gravity force laws. And it just describes much more data. It's more consistent. It comes from a universal force law. All of nature seems to be simplifying. It satisfies Mach's principle, which none of the others do. It is not based on the known approximations of these other theories, which are known to be false. It's just amazing how many things it can describe. Now, I had planned to take a break at this time, but we're running kind of late. What should I do? Should I go on?
Yeah, I think you should go on.
Okay. So now we're going to shift gears and we're going to talk about the creation. We've hinted at it a little bit, but we're going to go into more detail now.
So
the next...
Just for a second, those of you who can't hear, the hearing up here is quite good. Anybody wants to come forward, welcome to do so. Okay, go ahead.
Okay. So now we want...
On very center field, decay the speed of light. How does that relate to this decay of mass?
Okay. The speed of light is not a fundamental... it's not a constant quantity in this approach. This approach, the speed of light, is the velocity, the transverse velocity of in the electromagnetic fields that are attached to a charge. Okay, the conventional science would say that when an atom emits light, it escapes from the atom and is independent of the atom, because it has action at a distance as an assumption. In our work, there is no such thing as action at a distance, and every photon is just a ripple in the fields of charges. Okay, and those fields remain attached to the charge forever. They never detach. And so this ripple is going out, and the speed of the ripple is a function of the tension in the field. So if I am near the center of the universe, the tension, due to the presence of the fields of all the other particles, will be highest, and the velocity of light will be slowest. If I'm near the edge of the universe, there's very little matter nearby to produce tension, and so the velocity of light is much faster. That is the velocity of the transverse radiation. I must tell you that the velocity of the longitudinal radiation is always infinite. It is never finite. It's always infinite. And that's a very important point, because God interacts with the universe both via longitudinal and transverse radiation, and so he is able to act instantaneously at any point in the universe with longitudinal radiation. And only he has the energy to do that. You have to have an infinite source of energy. And no star or any other astronomical body has sufficient energy to produce longitudinal radiation of that sort. So anyway, so that's an interesting distinction. So Satterfield's idea that the velocity of light has decayed at this point in the universe where we are, it may be decaying. We don't know how fast it's decaying, but certainly on the outermost parts of the universe, it's much higher than it is here. But we can't measure it there. See, we can only measure it here. That we have to make model assumptions when we measure from distances like that. So it could be that the velocity of light is much faster as we get closer to the edge of the universe, and even though these stars appear to be very far away, they may not be that far. What we call billions of light years might not be that many light years if the light is traveling much faster out there. But it's not clear that they're that far away.
You said earlier that when you were talking about Poincaré, that he argued that relativity wasn't fundamental because constant C was considered essential to that argument, and therefore relativity is electrodynamic in origin. In other words, you were saying that C is fundamental to electrodynamics, and now you're saying C is not fundamental. It sounds to me like you're...
Well, C is fundamental in the sense that all the equations of electrodynamics are in terms of C. C is the fundamental constant of electrodynamics. It's not a constant, I guess you would say. Well, we don't really know that. I'm conjecturing that it may be different at the edge of the universe. We haven't measured it. If you look at the measurements that Satterfield quotes, I've been to scientific meetings where people have shown that the older measurements did not apply all the corrections that are applied to the more recent measurements. And if you go back and apply those corrections that were not known at the time they were made, that all the values are in agreement within the last, the fairly accurate values that we've made, so that you can't show any change in the last 150 years or whatever that we've been making accurate measurements. So if it is decaying at a small rate, but the data doesn't support that. There were a number of effects that were not taken into account in the early measurements of the velocity of light, which we now know about. So I wouldn't put a lot of stock in that idea, but it's possible that it is decaying. Like, for instance, the force of gravity is decaying too, but it's not very fast by today's standards. You can measure it by the rate at which the Earth is expanding, but the rate of the Earth's expansion is only on the order of 15 or 20 inches a year for the radius, and that's a very small quantity compared to what the rate it used to expand. And we can measure that with GPS satellites, but it's a very tiny quantity. Well, that's a good comment, though. I'll think about it some more. The next slide, we now want to look at what is the it turns out of all the parts of gravity, the part that relates the most to creation, the flood, and the division of the continents all relates to the decay of gravity. You notice how many astronomical phenomena we were able to explain by the decay of gravity. Here now I want to look at what the significance would be if we have a decay of gravity for the creation model itself. If in Genesis 1:3 we take the strict literal translation of the Hebrew word or, which is translated to King James light, but it means luminary, and in Hebrew, that's the primary meaning of the word. If we take that meaning, then we would have a star created on day one. It would immediately start to decay in size due to the decay of gravity. Gravity is what holds stars together, and that decay would cause the outermost part to cool due to the rapid expansion. Just like if you take any gas and let it expand rapidly, it will cool and form water and other things, whatever it is able to make. And so we would assume that as it expanded, the water being lighter would have been at the outermost edge, and the solid material would have been beneath that. And that seems to be the example of Scripture. And in the second day, what we find is God calls forth the firmament and separates the water above the firmament from the water beneath the firmament. And the idea is that God lifted the solid part of the star that had solidified from this rapid expansion up to the point where there was some water on the surface of the earth, but it didn't cover all the earth. Initially, all the earth was covered with water. So this, when he raised that up, most of the water went beneath the surface of the earth. And then as gravity continues to decay, this solid earth, which is covering all the earth now, with lakes, seas, maybe some seas on it, not big seas, but smaller seas, it cracks. And when it cracks, the water is able to come up from beneath. And when that water comes up, it can flood, there's enough water there to flood the earth. But as gravity continues to decay, the earth gets bigger. And now there's not enough water, because it's a fixed amount of water, there's not enough water to cover the surface because the surface is bigger. We estimate that today the earth is 70% bigger than it was before the flood. Let's look at some scripture passages and see. This talks about, this is the translation of Genesis, and it has the luminary in there. Let's say I want to look at the next passage, next slide. God created the earth upon the waters. And here in Psalms 136, 6a, it says, "To him who stretched out the earth by expansion upon the waters." This again agrees with this idea of the decay of gravity. The next passage, this is God stretched out the heavens and the earth. This is from Isaiah 42:5. "Thus says God, the Lord, who created the heavens and stretched them out, who expanded the surface of the earth by stretching." This is a literal translation, not quite exactly what's in the King James, but it's if you look at the Hebrew, you can see how I got it. And then the next passage, God stretched out the heavens. This is in Isaiah 45:12. God says, "I made the earth and created man upon it. It was my hands that stretched out the heavens, and I commanded all their host." And also, it looks like the stretching out, these are continuous processes in the Hebrew. And a continuous process is in agreement with the notion of the decay of gravity. So if God created all the stars near the earth, relatively speaking, and they were bound together about the center of the universe, and then gravity began decaying rapidly, these stars, which were rotating about the center, would now be moving out, just like the outer arms of the spiral, and they would be expanding, and the whole universe would be expanding. And so we have this idea that there is expansion of the size of the universe going on, and that is consistent with this idea of the decay of mass or gravity. The next slide. This is God stretched out the heavens from Jeremiah 10:12. He hath made the earth by his power, he hath established the world by his wisdom, and hath stretched out the heavens by his discretion. This gives the idea that it's a process. It talks about he did it by his wisdom and his discretion. It doesn't look like it's a one-time act. And so I want you to see that. And again, it's emphasized again in 51:15. He hath made the earth by his power, he hath established the world by his wisdom, and hath stretched out the heavens by his understanding. And so, if this is true, this means that the flood and the division of the continents and the future melting of the continents were all scheduled from the first day of creation. In other words, God put into effect a process which is going to determine that schedule. And because he didn't intervene again, it looks like, to do anything when each of these things occurred. Well, there's a lot more passages here. I need to get it on. We were running out of time. So let me advance to the flood of Noah. We'll go to the screen for that. You can see a picture of the water. The Bible says that the flood of Noah covered all the high mountains of the earth to a depth of 18 cubits, which is about 25 feet or something like that. It's very interesting. It wasn't really deep above the highest mountains. It was only 25 feet. And so it indicates there was a finite amount of water, but there was a lot of water, and you can't cover local mountains without the water going all over the earth. And so it has to be a worldwide flood if that statement is true. And so that's consistent with the idea we have that the earth continues to stretch, and that stretching enables the waters to recede into the oceans. And we have evidence of that, and I will show that in a few minutes. The next slide shows the layering that we see. I own oil and gas wells, and every time they drill, I get a report on all the layers they go through, and I get a map. And there's layers of water still down there, and there's all kinds of layers of sediment. And by the way, the sediment on this continent, the United States, is about a mile deep in most places. So there's a lot of sediment there from the flood. Next slide shows the process of the layers of the firmament or crust of the earth splitting, and all the water coming up into the air. Some of it's coming up into the sky in strong streams and then falling as tremendous amounts of water. Some is just rising and flooding that way, and some forms rain eventually. I want to show the next slide on the division of the continents. If you follow the genealogies in Genesis 10, 21 to 25, you see that there was a great-great-great-great-great-grandson of Noah, who Noah knew apparently, named Peleg. And the name Peleg means division and refers to the division of the continents. And if you look in Genesis 11, verses 10 to 16, to see how old each of these people were when the next son was born, you can find out that it was 101 years after the flood that the division of the continents took